Hello everyone. So in the previous lecture we have seen the basics of Simulink. So in this particular lecture we are trying to, or I am trying to give you the best uh, from the point of view of the control system, to how to design control system in Simulink. So let's move to the folder in which I have considered the work that is in my MATLAB work. So I move to that folder. So first open the Simulink. Now this opens the Simulink. Now just try to make a untitled file. Now just try to take some blocks. First we are using commonly used, not going to continuous. In continuous you have to select the transfer function. So this is the transfer function block. Add it to untitled by right clicking. As you can see, this block is added into the Simulink. You can change the parameter as per your requirement. Let's consider a transfer function which is s plus 1, means the numerator matrix is 1 1 and s square plus divided by s square plus 2s plus 2. So here s square term is 1, 2s we have taken 2 and plus 2. So this is the transfer function which is created s plus 1 divided by s square plus 2s plus 1. So these are the parameters. When you double click it, these are the parameters which you need to modify as per your requirement of the system. So let's take an input and a scope. Let's select the source. Let's take an input as sine wave and sync as scope. Now these are not visible. Just click on this to check where are the blocks present. I think it is over here. You just select it and take it in front and then click this. I hope still not visible. Just go up and just click this. Not visible. Just move here and then click this. All are visible now. So this is for the scope to see the waveform, output waveform, and this is for the input. Just let's try to check the response of this particular system for sinusoidal input. First, we will change the system parameters or simulation parameters by moving into the model configuration parameter. This will open a pane and we have to select the fixed type solver and select here Euler method and change this value to 0.01 as a fixed step size. Now when you run this, this will simulate and give the response of this particular system for sinusoidal input. So this is the response of the system for sinusoidal input. It's look like to be a sinusoidal wave. We want to see both inputs in the same. Let's check. Let's change the number of axes to 2 and apply it, and this will create the second input to the scope. Is connected with the input. In the second graph you will see the input, and then the first graph that is above will give you the result of output of the system. Just run it and look at here. So the first one is the output, and second one is the input applied to the system. So I hope how to convert a scope into multiple screens or multiple plots you can see by changing this setting, going to the setting, changing the number of axes to 2. You can also limit the data point, but we are always required to have multiple number of data points, so we can skip this point by unticking that particular option, so that all the data can be visible to the user. And this is for auto scale. So this is the open loop response of this particular system for sinusoidal input. If you want to check it for step input, just replace this input from sinusoidal input with step input. Try to add this. Just click this. I think this is also here. Just try to put here so that all are visible. Now just try to connect with this. So here also you can see that this step input is applied to the system, and you are watching all these output and as well as input in the scope. So let's run it first. So this is the response of the system. First one is the response of the system for particular input, that is step input, and this is the input applied to the system. I hope this is clear to you. So this is the main way you can connect any transfer function inside Simulink, and you can simulate it for different inputs. Let's try to check for any other input. Let's take a pulse generator, or you can directly drag this. I hope I shut it down. So just drag it here so that it will be nearby our main Simulink model. You just connect it and try to run. I think this is the response of the system, first one, and the uh, below one is the input applied. Let's try to change the pulse width of the signal. Let's take pulse width as 30%. Amplitude remains same 1, and period let's take 5 seconds. Apply it, okay, and run it. You can see this is the input applied, and this is the response of the system for this particular input. I hope you understand how to make any system inside Simulink and check its open loop response by providing different inputs to particular system. And you also understand how to connect these input with multiple this input to the multiple port of the scope. I think this is clear to you all. If you have any query, you can ask me after the lecture. So let's try to change this transfer function as well to see the response of other system. Let's make it -2 here and try to simulate for the same input. Just check the response. So this is the response. This actually due to minus sign present in the transfer function. the system is unstable, and when you provide any input, the response of the system will be going towards infinity. When you run for the longer time, let's change the simulation time to 100. When you run it, it will give you around infinite value. When you auto scale it, just see here that the output response is going towards 10 raised to the power 43. That is moving towards infinity. So the system is unstable for this particular input. Let's change the transfer function to some other transfer function. Let's take this as a transfer function. So take this s plus 1 upon s square plus 4 as a transfer function and try to simulate for this particular input. We will get this response. This is the response of the system for this particular input. Input is the below one, this one is the input, and this one is the output of the system. So you can see here that this output is something like sinusoidal or varying sinusoidal with varying amplitude. I hope this is clear to you. Now, if you want to log your data from Simulink to workspace, there are some specialized block present in the MATLAB which you can use it. Uh, the first one is for exporting the data from Simulink to workspace. So you have to go to, I think, sync, and you have to select this to workspace, that is sim out, exporting the data from that Simulink to workspace. So you have to select this, and when you click it, you can see here that limit data point to infinite we have selected, and you can change the name of this variable as output if we want to take the data points of output, and rename it to output and convert this time series into array, and then you can apply and then OK. Connect it with output of the system, and when you run it, just change this to 10 seconds, and when you run it, you can see output variable is generated in the you can look at here that output is generated for that is the data point comes from data point inside the Simulink will come out into the workspace. This is the data points. You can plot it by simply connecting it to this and go to plot. Just try to plot it. This is the response of the system in MATLAB programming, and you can check it over here with the scope. So when you put it here and put here, these both response are same. This plot is just versus sample, and this is with versus time. So you need to sim out time as well to draw the perfect figure. Let's convert it to the main figure, which will look like the same as in Simulink with that of plot by using the plot command. So take a clock inside. I don't know where it is. So I think this is the clock. We have to drag it here. Just delete this, and you just copy it and then paste it. This will convert to and put it here time, because the clock will give you the time value. You can write time. When you run it, both time and output will be saved in workspace. If you want to see, you can see here that time and output both are saved in the workspace. So you can draw the plot by using the command plot x comma y. In x we consider time, and in y axis we consider output of the system. So this is the output of the system. If you want to see and correlate with Simulink result, you have to just check it out. You can see here that this response and this response are same, exactly same. So I hope how to log data from Simulink to workspace. You can use the SimOut block inside, I think, pane sync. Now you can also call the data from uh, workspace to Simulink by using simin. By using the block source, go into the library source and select simin, put it inside, and when you double click on it, you have to just give the name of the variable, that is output, which data from the workspace you are trying to import inside the Simulink. You have to just give its name, and any other parameter which you want to change. I think that is sufficient. Just click it out and just change this number of x's to 3, so that you can apply third input as well. So when you connected it with this, you can see the third one and the first one are same. When you run it, there is a error, invalid matrix format, variable specified as workspace input in. Okay. So you need to convert this output variable with must contain two values. That is, first one is the time instant for which it is getting the value, and the second one is the output value. So we have to convert this output into two columns. So let's first copy this by control C and paste here, and just this is the value of output, and take time, copy it and paste into the output, the first column of the output. So this is the time and this is the output value, which are stored in the output variable. So when you run it, this will execute, and you can see here that this output and this output are same. Both are output values. You can see both are same result. The first one, the first plot, and the third plot, both plots are same. I hope this is clear to you, how to import the data, from workspace to Simulink, and as well as exporting the data from Simulink to workspace. We have two specialized block, that is, this first one is the to workspace and from workspace. I hope this is clear to you all. If you have any query, you can ask me after the lecture. Now the next is, you can create subsystem inside this. So let's take, you can go into the port and subsystem. Just select this atomic subsystem. if you have multiple different types of systems are available in the Simulink, you can make it a subsystem of that just by simply clicking on it. You can see here that input is directly connected to output. You need to just convert it and just paste this system inside this, and this will behave as an input to the system, and this will behave as the output of the system. So this system is inside the subsystem, and you can see here that this will be the system, and you can write its name as a system system TF, system transfer function. You can just put it over here, connect it, and when you run it, this will give the input to the system and generate the output. There might be some error. This is giving error. I think output is change overwrite. When you I have converted this now first time into we have converted this into the two uh, two column we have created, and many rows are there. So this will be converted back into the single column just because it the output will get overwrite. So let's convert it first into the same. Let me first copy this and paste inside this column. Take this time, the output variable, put it in the first column. So this will create the output and rename it to, so that it can remain whenever the Simulink model runs. Override will not happen now, and change it to output 1. And when you run it, you can see here that this is the response of the system, and this is the stored response in the workspace. Both are same. So I think this input, you can change the name of this port of input port. Let's say take input and take this as output. So this will create the subsystem of the subsystem with input as a input to the system and output as a output of the system. So I hope how to create this particular any particular subsystem is clear to you all. Now the next one is, you can check the open loop response of the system for any particular system. So let's try to make it in feedback. What is the response of the system when feedback introduces? So just delete all these branches, all these connectors, delete this. You can put time here just to make a feedback. You have to take the adders. Let's go to commonly used block, select an adder, just place here. This is the input, and this is connected to output, and the error between input and output will be fed back into the system. So convert this as a error, and this is the output of the system. Basically it is input, so let's change it. to input of the system, but you are finding error. Put it input E, just connect it with the output of the system, and this output will be fed to the. Here we have considered the positive feedback. Let's check it the result for the positive feedback. You can see here that this is the response of the system with positive feedback. Now let's check for negative feedback. Convert this plus sign into a minus sign. You can see here that this is the response of the system for negative feedback. So I hope the system with negative feedback will give this result when a pulse of 30% duty cycle is applied to it. Let's check it with input as well. Please place a multiplexer inside and convert these axes into a single axis. Just Control X and Control V. You can put here the output and the input. You connect it with the scope and then run it. You can see here that pink one is the input to the system and the yellow is the output of the system. So I hope this is clear to you all guys. So moving forward to the next type of simulation, we can convert this system into a non-linear system because this transfer function is a linear system. So let's try to convert it into a non-linear system. There are different non-linearities available within the MATLAB Simulink. So just go to discontinuities, library discontinuities, and you have to select any of the non-linearity. So I have considered here saturation as a non-linearity and place it inside. Let's limit the input to, or you can change its location. After the response, and you can place, just put 1 to -1. This will create the nonlinear system. A transfer function with a non-linearity will create a non-linear system. Cascading of the linear system with non-linearity will give you a non-linear system. So this will create a non-linear system by using saturation, and when you run it, this will give you the response of this particular system. Let's check the response when amplitude is 10. So this is the response of the system for amplitude 10. You can see here that output will never go above 1 and never go below -1. So I hope this is clear to you all guys. How to introduce nonlinearity. Let's change this nonlinearity with other nonlinearity. So take it backlash. When you run it, this will give you the result like this. Whenever you change the non-linearity inside the system, the response of the system will vary as per the non-linearity introduced. So I hope this response is clear to you. Let's try to check it for open loop. In open loop, you have to delete this feedback, and when you run it directly, as an open port will take zero value. You always remember that in any Simulink model, any input open will be considered as zero. So when you run it, this will give you the open loop response of the system with backlash as a non-linearity. Let's try to check for saturation non-linearity. So this is the response with saturation non-linearity. So I hope these are clear to you. The important part is how to save. You can save it by clicking File, then go to Save As, or just write any name. Uh, I take experiment or exp1 underscore simu. Simu means for simu stand for Simulink. So when you click it, it will be a SLX model, or you can convert MDL file also. You can choose any of the two, SLX or MDL. MDL is older version of the Simulink model. SLX is the latest. So always try to choose SLX because it will be supported in any of the MATLAB. It is the latest as well as the older one. So you have to always select SLX. It is better to select SLX. Now this will be saved. When you close it, you read again want to open it, just go into this folder and search for exp. You can see it is here, exp1 underscore simulink slx. So this will be saved file now. So I hope this is clear to you. You can also convert this file into a M code by going into save as option, and you can write here as a exp or exp.m. When you save it, I think it will give you an error. M is invalid because we have put an M sign, dot sign. This will not be able to, we are not able to save it. So you can convert it from this. You have to rename it and change this extension from SLX to .m. When you click enter, this will be converted into M file. When you run it, this type of coding will be generated, and I hope this coding is useless. So just right click on it and rename it to SLX. The time will be converted into .slx. Now open it. Now let's try to save it in another format, that is MDL, and save it as a MDL file. You can see here that this is the MDL file, and then rename it this MDL to .m. And when you just open it, you can see here that this MDL is converted into the your main code. You can run it. There is some error. I think this is the wrong. This, if we have any, let's try to run it. 13, 34 maybe. This is extra. Let's run it. There is another error. So there are some error inside this code. Otherwise it will run. So rename it to MDL. Let's try to open it. Let's try to run it. I hope the response is correct. Let me check first. Just delete this and add this. Just save it. So let's try to change again to M file. And when you open it, this will give you the, I think this dollar sign will give you another. There might be some error. Rename it to MDL. There is another way to convert it into the code. You have a code generation option. You can convert into C or C++ as per your requirement. So just leave it. There is some error. Due to this, the higher version of the MATLAB, but in the lower version, the conversion from MDL to .m will definitely work. There might be some changes in the MATLAB after 2014, so this will give you an error. But in the earlier time, I used to convert this MDL into .m file. That code will run and give the same result. So I hope this saving and all these things are clear to you. Let's clear and clear all the variables. Just also I want to clear this command history. I think right now command history clearing is not. Now go to home. Workspace is already cleared. Now command window, and this is command history. You can clear it by using this command and just change it layout to the default and go and tick dogged. So you can see here that command history is clear. Now these basics of simulating a model inside the MATLAB or a system inside the MATLAB is clear to you, and how to import and export the data from workspace to uh, Simulink and Simlink to workspace is clear to you all. Now moving to forward, designing a system in a state space. So just going to the Simulink, open a new Simlink model and just use containers and go and select state space. So when you expand this will give you the. Now consider the system. So you can see here that there are four matrices are there, A, B, C, and D. You have to fill all these matrices here. So let's take an example with a system having A matrix as 0, 1, 0. Let's put a column. This is the first row, 0, 1, 0. The second row is 0, 0, and 1. The third row is -4, -3, and -2. Just put a bracket over here, and in the B matrix we have 0 and 0 and 4, and in the C matrix 1, 0, 0. D matrix is 0, and just initial conditions are 0. You can just apply and then OK. Now you can see the response of this particular state space model by applying input and seeing the response on scope. This is for checking the response. This is for applying the input to the system. So this is the response of the system for step input. You can change the simulation time to 100 seconds. See here, this is the response of the system. This is the open loop response of this particular system. Now you can add nonlinearity as well to this particular state space model or state space system by just going into the discontinuous and then selecting a saturation and applying this saturation in between. Move it backward so that this will connect automatically. When we run it, this will be the response of the system, and it will now not go beyond the, it will limit the value of input to 0.5. Just change its location from input towards the end of the output, or connect the value to output. You can see here that output will not go beyond 0.5 and minus point and go below minus 0.5. Just change its value to 1, tab, and -1. We run it. You just see here that response is going towards 1 and will never exceed the value 1. I hope this introduction of nonlinearity is clear to you with the state space model. Now you can also design it in closed loop by adding a uh, adder, change it to plus, just put it inside, change this plus to plus and minus, connect this minus with the response of the system. Just out of it, you can see the response of the system, and open loop system is stable. I think when you give the step input, the response of the system will be step after a certain period of time. But when you introduce the feedback, the system become unstable. Stability of the system decreases. So I hope this is clear to you all. Now moving forward, let's try to make it with, sorry, there might be some error. Now we can design the same system, any type of system, by using control system toolbox, which is available inside the Simulink library. You can see here that control system toolbox on an LTI system. You can select this block for designing any system. You just remove this and add this inside. So here you have to give the statement, or you can write state space, or any way you can define. You have to write the function inside this LTI system variable. So we have taken this transfer function and taken the transfer function as s plus 2 in the numerator and s square plus 2s plus 2 in the denominator. So s plus 2 will be a matrix with 1 comma 2, and s square plus 2s plus 2 in the denominator will be as 2 comma 2. When you change this, this will be converted into s plus 2, a transfer function having 0 at location 2, and characteristic equation, or the pole part is s square plus 2s plus 2. So the transfer function is s plus 2 divided by s square plus 2s plus 2. This will be also a LTI or a linear system. When you remove this non-linearity, you can check the response of this particular system. I think this is the response of the system for step input. Now we want to verify it result with the help of the transfer function block. So let's select the transfer function block, just go inside, and here I think this is the transfer function. Let's change the transfer function to 1 to the same transfer function 1 2, and taking this is a 2 and 2, apply it, OK it, and put it here. I want to check the closed loop response of the transfer function block as well as LTI system block will give the same result or not. So I want to compare the results. Report. You have to create the same feedback model here also. We have taken the same input. Just wait a minute. Just convert this into uh, so let's take input same feedback from this particular transfer function block, and output will be plotted on the second axis of the second plot. It's connected here. When you run it, you can see here that both the responses are same. Either you can select the LTI block as well as the transfer function block, the response will be the same. I hope this transfer function block as well as LTI system block are clear to you. Now let's take integrator in between both the blocks. So will not be able to connect. We'll drag it backward. Now it is connected. Copy it and place it inside. We run it, both the response will be same definitely. Let's check it. This will give you the response of the system for both the LTI as well as transfer function systems, and both system are same and give the same result for by introducing the let's try to check by introducing derivative. Here the derivative block is this du by dt. Let's reduce its size. Control C and Control V. When you run it, so this is the response of the system for both the system in LTI and as well as transfer function form by introducing a derivative inside it. So I hope this is clear to you all. Now the LTI system in the control system toolbox, either you can choose or design your system with the help of control system toolbox, that is by using this particular block, or also by considering this transfer function as well as state space block. I hope this is clear to you all. If you have any queries, you can ask regarding this. Now, I have already discussed creating subsystem. Now, let me check what are the topics left inside this. So, I hope this is the basics how to design a transfer function inside Simulink and how to design state space model and how to use the control system toolbox, that is the LTI system block inside the Simulink, how to design subsystem, and how to import and export data in and out from workspace to Simulink and Simulink to workspace. All these topics are covered. Now, the next topic is designing of the controller for these particular system. This will be covered in the next lecture. So thank you very much for patiently listening.